Hello students, today we will start with the class 1 for unit 1 which is for computer network syllabus and so this syllabus consists of 5 units. We are going to cover all the 5 units and the 5 units specifies the layers of OSI model as well as you can represent this TCP IP model which is in use. OSI model is a reference model that also we will see in the forthcoming classes. So now we will start with the, as I said earlier, unit 1 is of physical layer and unit 2 is of data link layer and unit 3 is of network layer and unit 4 is of transport layer and finally unit 5 is for application layer, right? So now we will start with the unit 1. So apart from physical layer in your syllabus they have included how the internet is working also, right? So working principles of internet is also included in the first unit, right? So this is for computer network syllabus and we are going to start with class 1 for unit 1. So in data communication and networking, the basic components of data communication are clearly defined, right? So there are five main components of data communication. They are a message, sender, receiver, protocol, as well as the transmission medium, right? So these are the five components that are available in data that are mandatory for data communication, right? So, so now let's see each component separately, right? So there are five basic components. We will see each component separately. First one is message. So message or data is the content that what we want to transmit in the medium using whatever we are communicating nowadays to one person to another person is in the form of data, right? So the data can be of text, it can be of image, it can be of audio, it can be of video, or it can be of any other format, right? So text or so it can be of numbers mixed with symbols. So any format of representation is known as data, right? So these are the types of different data that are available. So message is nothing but the data what we are trying to transmit. So the information or data to be communicated is known as message. So example that what they have represented here, text, numbers, images, audio and video, right? So this is the first component, the data what we are going to transmit. So the second component is sender, right? So sender is nothing but the source. The person, so for example, if you take WhatsApp, the person who is sending a message to another person, the person who is sending is known as sender, right? So he is sending message to another person, that means this is the source and this is the destination, right? So source, the device that sends the message is known as source. Example, it can be a computer, smartphone, server or sensor. Next is the receiver. A receiver is nothing but the person who receives the message, right? So for example, the sender is sending a message as hello. This hello is received by the receiver in its end, right? So now hello is the message what we are transmitting and S is the sender who is sending hello and D is the receiver who is receiving hello, right? I think now you have understand these three components, message, sender and receiver. Receiver is nothing but the device that receives the message. Example, same example for sender and receiver, it can be a computer, smartphone or printer. Next comes transmission medium, which is nothing but the channel, right? So now mobile phones are using the transmission medium. That is what we are using for mobile towers that are available, right? So that mobile towers will transmit your signals from one place to another place. So that is the transmission medium. So the transmission medium is wireless for mobile phones. Like that, we can also wire the transmission mediums, example cable TVs or any other transmission through wired medium that also available, right? So that is what represented as transmission medium. It can be either wireless or it can be wired. And you can represent this wireless and wired. You can represent this as guided medium or unguided medium. Wireless is for unguided medium, right? So it is vice versa. Wired is guided and wireless is unguided, right? So here it is the definition for transmission medium, the physical path through which the message travels. Example, twisted pair cable, coaxial cable, fiber optic cable and radio waves, right? So far we have completed four data communication components. The last component is the protocol. We need a set of rules that should be followed while you are forwarding a message from the sender to receiver. So that set of rules is nothing but the protocol, right? So a protocol is a set of rules that governs data communication. So it defines how, what, when data is communicated, or whatever, how the data should be transmitted and when it should be transmitted, and what type of data should be transmitted, all are decided by this protocol. It is nothing but set of rules, right? So you should not forget what is protocol. It is a set of rules that governs the data communication. Some of the examples of protocols are given here: transmission control protocol, internet protocol, hypertext transfer protocol, file transfer protocol. And I think you may familiar with this HTTP, because normally in web browsers we are using this HTTP to get the content from the web server, right? Right. Now, now let's start with the next topic. So this is the basic introduction about the main components that is needed for a communication in a data communication, right? So next we will start with the second topic, which is nothing but internet. So internet as a core, it is a vast global network for interconnected computers. This system enables devices to communicate and exchange information using a standardized set of rules known as protocols. Right, so whatever basics we have studied so far, here also in internet we are going to interconnect different computers with different networks, right? So there may be so many number of networks that are, all the networks are interconnected, that is what represented as a global network, right? So the system enables devices to communicate and exchange information using a standardized set of rules known as protocols. Again, a protocol is nothing but it is a set of rules. When a web address is typed into a browser, a complex ballet of technologies is instantly activated to retrieve the desired web page. So that is what I told. In client side, we will have a web browser. The web browser can be, what are the different types of web browsers? You know, it can be Chrome, Google Chrome, or it can be Explorer, Windows Explorer, or it can be Opera. So many browsers are available, right? So many browsers are available. So that browsers are represented as a client side tool which is used to communicate with the internet, and so that is what web browser. And web server is nothing but this web browser is getting data from a server which is running at the server side, right? So this is known as client side. Web browser is used at client side, and in server side we will have web server, and there will be a communication, bidirectional communication. So this web browser will send a request, and for that request this web server will respond, right? So that is known as bidirectional communication. It will send a request, and for that it will get the response, right? And web server will process your query, and then it will generate the response for the query, right? So that is what here they have represented. We are executing ballot of technologies instantly activated to retrieve a desired web page. This process can be accurately imagined as sending a physical letter through a global postal service, right? So it is an imagination. It is not exactly the same how we are. So before days and all, how the communication is established. Only we will use letters to post from our home to any other relative's home, right? But we have to wait for the reply letter. Uh, so the time duration will be long. But nowadays we are using WhatsApp, which is a recent technology what we are using for communication medium. So instantly the receiver will get the message and he will respond for the message through the internet, right? So that is what we are representing here. So this is what introduction about internet. Next, we will start with core components of internet functionality, right? So as I said earlier, browser is nothing but the client. In the client side, what tool you are using to connect to the internet is known as browser, right? So the web browser acts as a client server, and it is the user primary window to the web. Its fundamental role include providing graphical user interface for typing URLs and clicking links, right? Right. So obviously we will use Google Chrome. Just click on that Google Chrome and type whatever website you need. That is known as the link for that website, right? So first you will give any content in the search button, automatically it will be listed with different links, and you will click on the link whichever is mandatory for the particular website. That is known as URL. URL is nothing but uniform resource locator, right? So using this uniform resource locator, you can locate a particular resource. So it can be represented as uniform resource locator or unique resource locator, whatever it may be, right? So to locate a particular resource, you are using this URL and clicking the link. The browser serves a request sender. So that is what I have explained in the previous diagram. I think you may now understand, right? So the browser is sending a request to the web server, and the web server is giving the response to the browser, which is nothing but the client side. So the browser initiate communication by sending a HTTP or HTTPS request, right? So the difference between HTTP and HTTPS protocol is HTTP is hypertext transfer protocol. HTTPS is also hypertext transfer protocol with a secured parameter, right? So inspect of so that only the phishing attacks can occur only through the website similar to HTTP. So you should be aware of using HTTP websites before using. If there is a link only specifying HTTP, you should avoid that types of links, right? So nowadays HTTPS is an authorized links that can be used for communication, right? So it also functions as a protocol implementer, understanding protocols like HTTP and HTTPS to communicate efficiently. Finally, the browser is the content renderer. So the browser content renderer is nothing but we know HTTP is hypertext means we are going to represent the text using HTML or XML language, right? So HTML hypertext markup language, XML extended markup language, right? So using this language only we are going to write it. And I think you know basics about HTML language, how to represent a particular body, head, everything should be enclosed with a tag information, right? So head information, body information, right? And That is how we are representing as a HTML file, right? So that is what we are representing here. So whatever you are writing inside this tags, that will be presented in the corresponding represent. If you want, you can bold it. If you want, you can italize. You can give some styles to the fonts, or you can give some other colors to the fonts. Anything, whatever you want, you can represent using this hypertext. That is why it is represented as hypertext. So finally, the browser is the content renderer. Whatever is available within this tags, that will be rendered upon receiving the content. So that is what I have represented. That is what it is represented here as HTML, CSS, JavaScript, images, etc. Right. So once you have clicked Google web page, you will see Google image. Right. So that is what the image is included in the HTML file. So HTML hypertext markup language, CSS is cascading style sheet. If you want to use any styling, for example, all the letters in your web pages should be in a particular style, then you can choose the style, cascading style sheet. So there are different methods, inline method as well as external method and internal method for representing this cascading style sheet. And JavaScript image, JavaScript is nothing but we are using JavaScript to present the content that is used for communication with the database or web servers, right? So that is what represented here as JavaScript and images, etc. This all this content will be rendered and presented as a single page for your view. And once you have clicked any button or links, automatically it will be redirected to the next content. So next comes the web server. So web server, from the name itself you can understand it is the server side, right? So the web server is the computer program often residing on a physical machine that stores and delivers website files, or you can represent website resources. It can be of any type of resources, whatever you are required, whatever content you require, it will provide that resource. So it can be a HTML document, or it can be an image and style sheet or browser upon request, right? So whatever request you are sending from the web browser, web server will give the corresponding response to the web browser. So this is the request and this is the response. So as the responder and the client, so it is similar to client server model, because web browser is acting as a client and web server is acting as a server. And its primary role include acting as a content host for all website files and the request listener, constantly waiting for incoming requests from the browsers. So it will be in a listening mode. Always servers will be in a listening mode. Whenever there is a request, the connection is established and automatically it will start responding to that particular connection. So always server will be in a listening mode. So when a request arrives, the server processes it. This processing might involve locating the requested file, running server-side scripts. So there are two types of scripts. As I said, we are using JavaScript for writing the codes. Either it can be a client-side script or server-side script, right? So it can be so the script can be using PHP or Python or JavaScript to generate dynamic content or integrating with databases. So that is what I have represented earlier. We are using JavaScript for connecting with the databases. Or dynamic content is nothing but the content, it's not static. So for example, if you load a Google web page, every day they will have a theme to represent in their Google image, right? So the Google image will not be static for all the days, right? So one day they will have one particular theme, or one day they will represent a honor about a particular personality, whatever it may be, right? Whichever is famous, that will be represented in the Google image. After processing, the server sends a requested web content or an error message. If the resource is not found, it will send the error message back to the browser as the response sender. That's all about web server and web browser, which is the client. Next, we are going to see how to address and locate the particular resources in that address. So the addressing of the particular resource is using this uniform resource locator that already I have told you, which is used to, for example, in web server, if you consider this as a web server, it consists of so many number of resources within it, right? So to get a particular resource, we have to represent using this uniform resource locator. So it is a unique global address for a specific resource on the internet. No both resources will have the same URI, right? So that is what it is represented as unique. No both links will be same, right? So it ensures it is discoverable and accessible. A typical URL structure begins, so this is very much important. These are the components of the URL. First component is protocol, right? So it will start with a protocol, and I will write how HTTPS colon slash slash, right? So this is how it is starting with the protocol, right? And then example HTTPS they have given, and then we have to specify the access method, right? So access, here we are using www, which is the domain name specification, World Wide Web. Www is nothing but World Wide Web, right? The human readable name of the server, so World Wide Web followed by dot and then the domain name. So domain name is nothing but, we cannot able to remember the IP address of each and every web servers. So DNS comes into picture, which is domain name server. The duty of this DNS is to map between the IP address and then the domain name, right? So normally all web servers will be executed in a particular IP. For example, if you are clicking a Google also, you can able to see the IP address which is loaded in the bottom taskbar. The IP address will be keep on changing because we cannot predict in which server the request is landed, right? So that is what. So mapping between the IP and the domain name is done by this domain name server. So to make remembrance easy, we cannot able to remember numbers. Instead of that, we are going to give a particular domain name for that particular IP address. So example, in real world, there is some websites they are providing for domain name itself. For example, GoDaddy, they will provide domain name for the communication, whatever IP you are having, for that IP they will map a domain name, and you can establish your organization using that domain name. And for that you have to pay for it, right? So www.gct.ac.in, that also you can give to check your results. For example, if the exam results are published, you can go for this particular domain name, right? So that is what given here. Here they have given www.example.com, the human readable name of the server. An optional port number may also be included, but it is not mandatory. But if you are trying to execute a particular web server in your system, obviously the system will use a loopback address as 127.0.0.1, and then the port number you can represent here as 5000, right? So this is an optional one. So instead of writing so this is known as local loop address, right? So since the web server you are executing within your system itself, it is known as local loop address, and this is the port number for it, right? So port number is nothing but, it is the so IP address and port number is the combination of IP and port, is known as socket. It is known as socket, right? So through HTTP the default port number is 80, and HTTPS, the default port number is 443. Automatically no need to specify within this domain name, right? So that after domain name, port number is optional. If you want to give, you can give, otherwise you can leave it. Automatically it will take based on the protocol what you are using. So next comes the path details. This is very much important. So this path details will determine the resource on the server, right? So the resource can be a file on the server file system. So it is also an optional component, because if you go to this domain name, automatically you will have several buttons or menus to navigate to a particular resource, right? So so this path component include query string for the parameters and fragment identifier, right? So parameters that specify whatever the parameters you want to pass. For example, if you log into a particular website, right, you by giving your username and password, automatically that username and password will be encrypted and passed as a query string parameter, right? Which points to a specific section within the page, but it is processed solely by the browser and not sent to the server. So next is domain name. Already I have told what is the domain name. So here the domain name consists of several levels: top level domain name, second level domain name, and subdomains. Right. So the domain name should be the top level should be from right to left. Right. So for example, if you are representing gct.ac.in, India is the topmost level domain name. Next comes academic, which is the next level domain name, and next comes GCT, which is the next level of domain name. So this is the top level, next level. So next level. So this is how the hierarchy looks like, right? So this is how the hierarchy look like, and you can represent top level domain name, first level domain name, second level domain name, like that it goes off, right? So these are the representation of domain name, and already I have represented what is domain name system or domain name server, which is used to map between the IP address and then the domain names. And next comes IP address. This is a unique numerical label assigned to every device connected to the network, right? So this is also unique. So far we have seen URL is also unique, and then the IP address is also unique for the each and every device connected to the network, serving as a actual address computers used to locate the communicate with each other, used to locate and communicate with each other. And it is similar to a phone number for a device. So the older version is IPv4, but still also the older version is existing. It is not obsolete, it is also working, and nowadays a newer version is also supported. So older version IPv4 is of 32 bits and IPv6 is of 128 bits, right? So since it is 32 bits, you can connect up to 2 power 32 addresses. So that since the addresses are exhausted, we are moving on to IPv6, which you can able to connect 2 power 128 addresses, right? So that is what they have given here for IP address. Next is data transmission via packets. So data sent over the internet, whether it is a request or a download file, it is not transmitted as a single continuous stream. Instead, it is broken down into small manageable chunks known as packets. Based on the bandwidth available, the given data will be chunked into number of packets, right? So packet 1, packet 2, packet 3, like that it will be chunked. So the packet structure, each packet contains a payload, which is a small piece of actual data being transferred. It also contains a crucial header which holds metadata such as source IP address, destination IP address, and the packet number in the sequence, right? So next is the role of the packet. So the packet are vital for reliability and efficiency. If one packet is lost or corrupted, only that small piece need to be retransmitted. right? So that is what the role of it. So not the entire message, only the particular packet should be retransmitted. Next is the how the web request is processed, that we are going to represent here. So the process of fetching a web page involves a precise sequence of events. First is DNS lookup, right? So after whatever URL you have entered, it will looks into the DNS and map with the corresponding IP address, right? So domain name will be mapped to the corresponding IP to communicate with the web server, right? The browser first asks a DNS resolver to translate the domain name into its corresponding IP address, right? So that is what I have represented here. And then request initiation. With the IP address known, the browser creates a HTTP request and immediately breaks into several packets, right? So consider this is the sender and this is the receiver. First, the request will be generated. After identifying the IP address with the given domain name, the request will be generated, which is HTTP request. And the packet travel. So this is the medium, transmission medium where the packet is traveling, and then through a network infrastructure like home routers and ISP. Internet service provider is represented here as ISP networks, and across many other routers on the internet, right? So the transmission medium, there may be many number of communication devices available, routers, switches, bridges, so many number of communication devices are there. So through that it is passing through and it is reaching the receiver side. So next is server processing. The web server receives and reassembles all the packets to reconstruct the complete HTTP request. It processes the request and generate a HTTP response containing the necessary content. Right? So the content includes HTML, CSS, etc. And then response transmission. The server breaks its response into its own set of packets and send them back over the internet to the client computer's IP address, right? So again it is transmitted towards it, right? So if you see here, after processing all the request information, the receiver is nothing but the server here. Server is responding with the corresponding answers for the request, right? And then rendering. So the sender will have the web browser with them. So that will be rendered, which we will get the final web page on the screen, right? So next is so this is very much important. In your lab exercise, you will start doing this network commands. Just go through the commands whichever is available here, and you can start working with it in the laboratory also, right? So first is the ping command. It is used to check the connectivity of the destination, right? So if you give ping space any domain name or any IP address, right? So domain name like that, for example, if you give www.google.com, it will start pinging the website google.com and it will generate n number of responses, right? So that means the destination is reachable, right? There is no packet loss, the destination is reachable. It is used to test the connectivity to the destination. Either you can give IP here, IP address here, or domain. Next is IP address show. It displays the IP address and its details of all network interface on the system. Next is IP route show. Whatever device, so for example, as I said earlier, this is the sender and this is the receiver, which is nothing but your server. And through this transmission medium, it may come across different types of devices like switches, bridges, routers, as well as hubs, repeaters, right? So many number of devices it will cross through. That route details will be represented in this IP route show. Next comes IP link set, right? So it can be, you can enable the interface. So interface is nothing but it is represent the NIC card, network interface card. So this it is used for connecting to the internet, right? So if the NIC card is not there in your system, you cannot able to connect to the internet. So you can either bring it up or bring it down. So next is SS. Investigates socket statistics. So socket is nothing but the combination of IP address plus the port number, right? And then next is NC, which is netcat command, creates direct TCP or UDP connection to send or receive data. And next is dig command, it queries DNS to receive to retrieve information about domain names. Next is trace route or trace path, takes the network path, shows the sequence of hops packet. So hops count is nothing but how many number of systems it is passing through. The system can be a communication device or it can be a source or destination to reach the destination host, right? And then the host name displays the current system host name, right? For example, if I am representing my system name as Devi, the host name will be displayed as Devi, right? And then curl, so this is C is for create, U is for update, and then R is for read, and L is for load, right? So curl command transfer data from or to serve using various protocols commonly used for downloading web content, right? So you are using this in the command line to download the web content. If you are using web browser, curl similar to how you are using a web browser to download content, you can use curl in the command line to download the content through command line, right? Next is wget, it downloads files from the internet non-interactively, right? So similar to curl, we can also download data using wget, which is used in command line to download the files, right? So, and then you can also check what is the IP address of your system. If it is Linux operating system, you can use ifconfig, and if it is a Windows operating system, you can use ipconfig, right? So, with this lecture, let's close the first session of first class. I think you can understand the concept, whatever we have discussed, and these are the basics about computer networks. Thank you.